Okay. All right. Here we are trying to find the components. So that's the left, right, and up, down parts of a vector for a vector that is 26 units long and is in the opposite direction. Its direction opposes this vector here. First of all, I'll talk about length of a vector. If we want to find out how long a vector is, we're simply talking about if I make that movement. So for example, the length of this vector, if I make the movement 5 units to the left and 12 units up, how far will I be from my starting point? And it's not uncommon if we're drawing a vector or trying to picture it, to draw it with its tail at the origin and its head up here at the point, in this case 5, 12, that we would land at if we followed that vector. It's just, remember, the vector though itself isn't fixed in any certain location. The vector is just a movement, right? It represents a movement in a certain direction. And here, if we want to find out how long this vector is, or how far something would move if it was moved by this vector, well, it's Pythagorean theorem. So here we're going down, and this is 12 and over 5. But notice we could have got that 12 and 5 from the vector itself. Right? So let's see. A squared plus b squared equals c squared. 5 squared plus 12 squared equals c squared. 25 plus 144 is c squared. 169 is c squared. And square root of 169 is 13. Yeah? Or see. So the length of this vector is 13. Now, we're trying to find the coordinates of a vector that is 26 units long, and it's not a coincidence that it's twice as long as the original vector. I mean, we could find coordinates for a vector that was any length at all and opposed and was in the opposite direction, but 26 makes it easier because it's basically going to be two of these, right, but going in the opposite direction. So we're going to figure out what that is. Let's see. We'd have to go, since this is forward and up, it's going to be back and down. So let's see. It'd be back 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we got to do it again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that vector, I have to zoom out a bit here if we can. Okay. So here, this vector. Okay. And this would be down here to the point -10, -24. And then, okay. So notice that this vector, its length is going to be 26. We could do Pythagorean theorem just to show that it really is. So that would be -10 squared plus -24 squared is c squared. That's 100 plus 24 squared. Left my calculator over there. I have to use my, let's see, 24 times 24. It's 576 equals c squared. So that's 676 equals c squared. And the square root of 676, well, is 26. Okay, so that's the length of this vector here. And you see by opposes its direction, you see how it's in the exact opposite direction of the original vector. Right? I draw a straight line together, going in opposite directions. Okay, so anyways, hopefully, with this example in hand, you can kind of figure out the one that was length 10 and I forget what the direction, but find the length of the vector you're given first. I think you'll notice the pattern. All right, good luck.